Hello everyone. In this lecture of work power energy series, we're going to understand the relationship between the kinetic energy and the momentum. So we all know that the momentum you might have read in the class 9th, the momentum we can say it is the product of momentum. It is we represent basically with the P and it is a product of mass and velocity. So it's a vector quantity and we know the kinetic energy we can consider body. Suppose the body is at rest, so we can write initial velocity 0 and this body is having certain mass, we can consider m. Now apply the force F and obviously it will start producing a certain displacement. After a certain displacement, suppose it gained the velocity v, and at a point, so suppose this point is B and this point is A. So at this point the velocity is not equals to 0. That means it has certain velocity, and if it is having mass and certain velocity, so we can say it is having kinetic energy. So kinetic energy of this body we can write will be half mv square. Now this kinetic energy we can write in this way also, k half m, we can write m square and v square. Now I have given extra m, so I need to balance it, so I'm dividing it by m. Okay, now what will happen, we can write this way also, half mv whole square and upon m. Now we know half mv, this mv is we can write momentum, so instead of writing mv we can write momentum. So we can say k is equals to half p square upon m, or we can say p square, these two will be multiplied by k, so 2mk, and that is the relationship between the kinetic energy and the momentum. Or we can write in this way also, p equals to root over 2mk, and that is our relation between the kinetic energy and momentum. This equation represents the relation between these two, kinetic energy and momentum. Now we're going to understand the application of kinetic energy and the momentum. What will happen? Suppose the two bodies having same momentum, then what will happen with the kinetic energy? So we can say the case one, when two body having same momentum. So we know the momentum is mv, okay, but doesn't mean that if a body is having same momentum that means that both will have same mass and velocity. It could be different. For example, if a body is having 2 kg mass and the velocity is suppose we can say 4, no, we can say take the 3 meter per second. So the momentum is coming 6 kg meter per second, kg meter per second. Okay, now suppose another body is having mass of 1 kg but the velocity is high. So again this momentum will be 6 kg meter per second. So you have seen in the both cases neither the velocity nor the mass is same, but the momentum is same. So you must consider that a momentum is same doesn't mean the mass and velocity will be same. It may be same, but it may be different as well. So we are considering a bigger body, suppose a heavy body. Okay, this heavy body is having mass m, and another body we are considering a very small body. Suppose this body is having mass m. Okay, both of them having velocity. This bigger body is having velocity v, and this smaller velocity suppose having velocity of certain we can say u. Okay, now in this case both have them the same momentum. The momentum is same. So we can write, suppose this is the kinetic energy of the body A. This is body A and this is body B. So we can write the KE, or the kinetic energy of the body A, we can write half P square, because the momentum is same, upon M, the mass of the body A. And we can write kinetic energy of the body B half P square because the momentum is same, so I'm taking P same, and mass will be M because it is a kinetic energy of a smaller body. Now this is the equation 1 and this is the equation 2 we can give. Now we will divide this equation and we will try to understand what will happen. Okay, so K upon KB will be half P square upon M upon half P square upon small m. We can cut down this. Now this equation will come like this. It will be small m upon m. Or we can write KB upon KA equals to capital M upon small m. Now we consider this capital M is a heavier body. The mass of the body M, capital M, is heavy in comparison to the mass of the body. So B. So we can write M upon small m will be greater than 1. So we can say the value of this entire fraction will be greater than 1. We can say this. That means we can say that KB upon KA is greater than 1. So we can say KB greater than KA. So what you have seen over here, that the kinetic energy of the body B is higher than the kinetic energy of the body A. So this is the condition. The heavier body will have less kinetic energy and lighter body will have more kinetic energy in the case when the momentum is same. Always remember, the lighter body will have more Ke and heavier body will have less Ke if the momentum is same. Now in the second case we will consider, suppose the two body having same K, then what will happen in this case? So we know the value of K is half mv square, and last time like we discussed, it may be the value of mass and velocity would be different. So let's consider two body again. We are considering this is the body A, okay, and this body is A having mass, we can say capital M, and the velocity of this body is v. Another body we will take, suppose this is another body which is B, and the mass of this is small m and the velocity is u. So again we can write the kinetic energy of this body or the momentum of this body, we can write down P is equals to A, because here the momentum is not same, the kinetic energy is same. So we can write P is equals to root over 2 m E. Okay, E we are taking same because the kinetic energy is same. This is the condition. It is a case 2. Okay, so kinetic energy is same, so we are taking this equation 1. Now for the body B we can write PB, we can write root over 2 m because the mass of the small body is m and energy is E. Kinetic energy is same. Okay, now we can say we can take the K instead of that like we have previously taken, but symbolization is nothing, just mathematical expression we are using over here. So the meaning will remain same. It doesn't matter what symbol you are taking. Okay, so this will be the equation number 2. Now we are dividing this. We are dividing this equation 1 with equation 2. So PA upon PB. What will happen? PB. Now see this one. We can write PA, we know it is 2 capital M under root, and we can say under root 2 small m E. Now we can cut down this EE and this will remain m upon small m root over. Now we already know the m upon small m is greater than 1, so the root of this one will be also greater than 1. Okay, will also be greater than 1. So in this means that we can say instead of writing this, we can say that PA, which is the momentum of the heavier body upon PB, which is the momentum of lighter body, will be greater than 1. The fraction of this will be greater than 1. So we can write momentum of heavier body is greater than momentum of lighter body. And that is the second case we discussed. So we can say whenever the kinetic energy of two bodies is same, the heavier body will have more momentum than lighter body. And in the case of kinetic energy, when the momentum is same, so we can say the the kinetic energy of the lighter body will be more than the kinetic energy of heavier body. And just opposite, when the kinetic energy is same, so we can say the momentum of heavier body is more than the momentum of lighter body. Hope you understood this. Thank you so much.